In this video, we're going to have a look at how do we identify a linear equation. So the aim of the video is for you to be able to recognize what is a linear equation from a non-linear equation. So linear equations come from linear relationships, and a linear relationship is one that is between two variables that when we plot onto a Cartesian plane will give us a straight line. We will see linear relationships in many real-life situations. An example of a real-life situation is water being added to a tank at a constant rate. If we were to graph the level of water in that tank, we would see a linear relationship being formed because there's a constant amount of water going into that tank every minute or every second, depending on what we are measuring. So let's have a look at some examples of linear relationships and non-linear relationships from Cartesian planes. So up the top, you can see some examples of linear relationships, and you can tell that they're linear because they give us a straight line. The straight line might be going up and it might be going down. It can go in all different other directions, but for it to be a linear relationship, it needs to be a straight line. Down the bottom, you can see some examples of non-linear relationships. Now you can see all of those three lines have different shapes and different curves to them, but they are all non-straight lines, and that's what makes them a non-linear relationship. So how do we identify a linear relationship without needing to plot it onto a Cartesian plane? Is we can have a look at the equation. If the equation has a power or indice that is other than 1, it will not be a linear relationship. So if it had an x to the power of 2 or an e to the power of x, those are examples of equations that would not be a linear relationship. If it was only a 5x or an x plus 3, that would be an example of a linear relationship. So let's have a look at some examples and we can apply this rule of how do we identify a linear relationship to some equations. So the first one is y equals fx plus 1. And we can see that all of our variables or all of our numbers only have an indice of 1. So therefore, because all of our variables have a power of 1, it is going to be a linear equation. Looking at question B, we got b equals c squared minus 5c plus 6. And we can see that we've got a c to the power of 2. So that means not all of our powers in our equation has a power of 1. So it is going to be a non-linear equation. Y to the power of the square root of x. If we were to change the square root of x into x to the power of 1/2, then it has a power other than a power of 1. So that equation too is going to be a non-linear relationship. Looking at D, m squared equals 6n minus 10. We can see that that has a m to the power of 2, which is greater than to the power of 1. So our D is going to also be a non-linear equation. We've got, and for E, we've got D equals 3t plus 8 and then divided by 7. Having a look, we've got no powers greater than 1 in our equation. So that equation will be a linear equation. In F, we have y equals 5 to the power of x, and we can see that we've got a power being other than the power of 1. So y equals 5 to the power of x is also going to be a non-linear equation. So that is some examples of how do we identify a linear equation. Anything that has a power of 1 will be a linear equation. Equations that have anything other than the power of 1 will be a non-linear equation.